قابلنا التحدي في مدرسة الحسام، أسسنا منهج علمي يبقى لهم دليل، بنواجه الأزمات بفعل ومش كلام، ونجيب لكل المشكلات حل وبديل، علشان إيماننا بربنا وحب ببلدنا، قدمنا ليكم علمنا علشان ولادنا، عهدك علينا مصرنا لما تعهدنا، توصل رسالة علمنا لكل جيل في مدارس الحسام.
After listening to our HIS lovely song, I think that you are all ready to start. Are you ready? Let's go.
Hello Prep 3, Miss Alia Muhammad, your science teacher at HIS with you. I miss all of you and I hope to see you again in the school after passing these hard days inshallah. This is the first recorded science session for you and we will complete lesson 1 in unit 2, which is the physical properties of the electric current. In this session we will measure the potential difference, how to know how to measure the potential difference, identify the resistance, verify Ohm's law, and calculate the resistance. First, let's remember together. Do you remember what are the physical properties of the electric current? Yes, we have the electric current intensity, potential difference, electric resistance. We studied before the electric current intensity and the potential difference, but we didn't take how to measure the potential difference. Remember also that the electric current passes from the high potential conductor to the low potential one. And what are the ways of connection in the electric circuit? We have series and parallel. Do you remember what is the device used to measure the potential difference in the electric circuit? Yes, we took the voltmeter. Voltmeter is different from the ammeter in the ways of connection, and also ammeter is used to measure the electric current intensity, while voltmeter is used to measure the potential difference. Voltmeter is connected in parallel in the electric circuit, not in series like the ammeter. But we use the voltmeter to measure the EMF and the potential difference in the electric circuit. Let's know what's meant by the EMF. If you get any battery, you will find a number written on it. For example, here we have 9 volts. What is this number indicates? This number indicates the EMF, electromotive force. We know that the electric current produced from passing of the electrons through the wire or through the electric circuit. And this movement of electrons move from the high potential, as we said before, to the low potential conductor. In this battery, we have positive pole and negative pole, and the electric current passes from the positive pole to the negative pole. If we measure the potential difference between these two poles, positive and negative poles, it will measure the EMF. But don't forget to get or to let the electric circuit opened to measure the EMF. And what is the measuring unit of the electromotive force? Its measuring unit like the potential difference, which is volt. And now we will know how to connect the voltmeter in the electric circuit. We said before it will connect it in parallel, but we can connect it in the electric circuit to measure the EMF. In this case, we will connect the voltmeter between the two poles of the battery and open the key. So it will measure the potential difference between the positive pole and negative pole of the battery, which is called EMF. Another case, we will measure the potential difference. So we will connect the voltmeter between the two poles of the battery, and in this time we will, between the two poles of the conductor, not the battery, and don't forget to close the key. And you should or you must know how to draw these ways, because it is a very important question. Now let's study another point, which is the resistance. First, tell me if you have two ways, way in a straight line like A, and another way which is zigzag line as B. If you moved through these paths, which one you will find more resistance, or you find difficulty to move in, A or B? Huh? Can you tell me? Sure, B. Yes, because in zigzag line you found more resistance to move in this way, but in the straight line it's more easy. So there is no opposition or small opposition in case of path A, while in path P you will find more opposition, or something which try to stop you, which is the resistance. Also, the electric current, when it passed in the electric circuit, found opposition or something which try to stop it. So it's called as the electric resistance. So what's meant by the resistance? Obstruction to the flow of the electric current in the electric circuit, or the opposition that the electric current face in the electric circuit. This resistance is measured by unit, which is ohm, according to the scientist George Simon Ohm. We will study it later. And it is measured by a device or an instrument called ohmmeter. We have two types of the resistance: fixed or constant resistance, and variable, which is rheostat. Fixed or constant resistance we can symbolize or identify the fixed resistance or draw the electric resistance in the electric circuit like this or this, while the variable one draw it as this or this. And now let's know what's meant by the variable resistance or rheostat. But first, can you tell me what is the relation between the electric current and the resistance? Return back to the definition of the resistance we said from just 2 seconds. What's meant by the resistance? It is the opposition that the electric current face in the electric circuit. So, as the electric current, or as the resistance increase, what happened to the electric current? It will decrease. Yes, very good. So there is an inverted relationship between the electric current and the resistance. So let's study what's meant by the variable resistance. Variable resistance, from its name, means a changeable resistance. So you can change its value. Why we can change its value? To adjust the electric current intensity, or to change the electric current intensity, and so it change the potential difference in the electric circuit. Because as we said before, as the electric current increase, the resistance decrease. As the resistance increase, the electric current will decrease. So by changing the value of the resistance, the electric current intensity will change. And now we will study the structure of the variable resistance, or the rheostat. This is the variable resistance. This variable resistance is connected to the electric circuit, and this is the way where the current in or enter the electric circuit. It is consists of a cylinder which is made of porcelain and surrounded by copper coil. This is copper coil, coiled copper wire, and copper bar, and a very important part which is slider made from copper, and it can move over the copper bar, and the current out from here. This slider can move along the copper bar to control the length of the wire enter the electric circuit. For example, the electric current enter from here, move through this wire, then to the slider because it is made of copper, then copper bar, and out from this position. If we change the length of the wire by moving the slider along the copper bar, we can control the length of the wire enter the electric circuit. So what is the function of the slider? It is used to control the value of the electric current and the potential difference by changing the length of the wire. Why? Why by changing the length of the wire we can control the electric current intensity and the potential difference? Let's explain. For example, if we have three paths or three ways, A, B, C, what do you think? Which one the electric current will find more resistance? A or B or C? Imagine that you are walking in these three ways. You will find more resistance in which way? Of course B, because it is not a straight line, it is a zigzag line, and it is the longest one. So the resistance here is maximum. So we said before, as the resistance increase, what happened to the electric current? Yes, the electric current will decrease. So at B we have high resistance, so we have the lowest electric current. If we compare between B and C ways, sure, B will be more in resistance and lower in the electric current, while C, it will be less. Why? Both of them are zigzag line, but B is longer than C. So by controlling the length of the wire, we can control the electric current intensity and so the potential difference. So the slider is a very important part in the variable resistance, and its function is very important. Don't forget. So if we want to find the relation between the length of wire and the resistance, what it will be? Again, what is the relation between the length of the wire and the resistance? By increasing the length of the wire, what happened to the resistance? Yes, it will increase. So there is a direct relation between them. Okay, if we want to draw a graph between the length of the wire and the resistance, what is the shape of the graph will be? It will be a straight line passing by the origin point, like this. We said this question before. What is the relation between the electric current and the resistance? Yes, it will be inversed. What is the graph? The graph will be drawn as this. So, can you tell me what is the relation between the length of the wire and the electric current? It will be we said that the length of the wire and the resistance direct, while the electric current and the resistance inversed. So the length of the wire and the electric current will be also inversed. And now the last point in our lesson, we will verify Ohm's law. George Simon Ohm. This is a German scientist who discovered or put a relation between the electric current intensity and the potential difference. What did he do? George Simon Ohm connected an electric circuit as it is, consists of fixed resistance, voltmeter, rheostat, batteries, key, and a meter. Then he made a table like this and record the value of voltmeter and ammeter, and then calculate V over I value. He connected the electric circuit as it is, then measured the voltmeter or see the reading of the voltmeter and recorded it, then the reading of the ammeter and recorded it, for example, and repeat this step many times. In each time it changed the value of the rheostat, or it changed the value of the variable resistance. He found that as the value of the voltmeter increase, in each time the value increase by changing the resistance, he found that the electric current intensity also increase. And then after calculating V over I, it will it gives similar value in each time. or constant number. What does this indicate? As the value of the potential difference increase and the value of the electric current intensity increase. So, what is the relation between them? Yes, both of them increase, so the relation will be direct relation. And this was the Ohm's law. He discovered or found the relation between the electric current intensity and the potential difference, which is direct relation. And this is Ohm's law. There is a direct relation between the potential difference and I. And each time, do you remember V over I equal constant number? He related this number or constant to the resistance and find the relationship between the resistance and potential difference and the electric current intensity. So the rule will be resistance equal V over I. From the rule R equal V over I, you know that the measuring unit of the resistance equal 1 ohm or ohm, and the measuring unit of the potential difference is volt. Electric current intensity measuring unit is ampere. So let's define what's meant by ohm from the rule. We said before that the ohm is the measuring unit of, yes, the measuring unit of resistance. So ohm will be the resistance when the potential difference equal 1 volt and the electric current intensity equal 1 ampere. Can you define ampere from the rule? Ampere, measuring unit of what? Electric current intensity. So it is the electric current intensity when V, which is the potential difference, equal 1 volt and the resistance equal 1 ohm. So again, what's meant by ampere? It is the electric current intensity when the potential difference equal 1 volt and the resistance equal 1 ampere. 1 ohm. This is the resistance. What's meant by volt from the rule also? Volt is the measuring unit of the potential difference. So it is the potential difference when the electric current intensity equal 1 ampere and the resistance equal 1 ohm. We defined the resistance before, but we have here another definition. From the rule, the resistance is the ratio between the potential difference and the electric current intensity. Final part in our lesson today, what's meant by the equivalent units. Equivalent units. We know that the unit or the rule of I equal Q over T. We have another rules for I. Yes. Here you have 3 triangles of the 3 rules that we have studied in this lesson. We have here also I equal V over R. Also from the 3 triangles we have W over V, which is related to the Q, by T. So this means Q over T. So also W over V by T related to I, or electric current intensity. Also we have W over Q by R. W over Q related to V by R. So W over Q related to V over R. This is also rule related to the electric current intensity. You know that the electric current intensity is measured by ampere. Ampere has equivalent units, means units equal to ampere. Q over T, what is the measuring unit of Q? Coulomb. What is the measuring unit of time? Second. So Coulomb per second equivalent to ampere. V over R. What is the measuring unit of V, or the potential difference? Yes, volt. What is the measuring unit of the resistance? It will be ohm. So volt per ohm equivalent to ampere also. From the rule, or the third rule, W, work done, the measuring unit is joule per V volt dot T second. So joule per volt dot second equivalent to ampere. The last one, work joule per Q coulomb dot R ohm. So by this way you can get the equivalent units. And now let's solve the assessment. Open your worksheet page 73. The first question is, define the following. Number 1, the electric resistance. Do you remember? What's meant by the electric resistance? Yes, the opposition that the electric current faces in the electric circuit. Second question, define the variable resistance or rheostat. Do you remember? The variable resistance or sliding rheostat can be changed to adjust the value of the current and potential difference in the circuit. Number 2, mention the function of the rheostat. From the previous definition, we can get the function of the rheostat to control the value of the electric current and the potential difference. Mention the structure of the rheostat. Do you remember the structure of the rheostat? This is the structure of rheostat. You have a homework, page 73. Open your booklet, page 77. First question, mention the Ohm's law. Do you remember Ohm's law? Can you tell me what's meant by the Ohm's law? The electric current intensity is directly proportional to the potential difference. Number 2, this is a very important question. Draw the Ohm's circuit. Draw the Ohm's circuit. Do you remember? You should or you must draw this circuit because it is very important. You have a homework also, page 77 and page 81. Again, your homework, page 77, 77, 73 and 81. Don't forget to solve your homework and send me your homework on Edmodo. I hope you understand the lesson, and please, if you have any problem, connect me, and don't forget to depend on the Egyptian Knowledge Bank.